Okay, this video is going to be a summary about atomic structure. If you remember 2 videos ago, it was about analyzing the atomic structure of the object. Now, in this video, what I'm going to do is I'm going to be trying to review with a summary about the most important points that you need to remember and you need to know about the atomic structure. And then with this point, we're going to be able to go forward, finish atomic structure, and then we can go more about electricity and how we can analyze and explain how the electricity works. What I want you to do is you're going to take notes of the most important points that you're going to see that are going to be in red, and also you're going to draw in your notebook all the sketches that are going to be drawing. Now, let's start right here with the first point. Now, the first point that we have here is that all matter is made of atoms, and this is the point, first point and the most important point is all matter in the universe is made of atoms, and we're talking about everything, no only like a book, a wood. We're talking about us. We are made of atoms. That means everything in the universe is made of atoms, but atoms are made of protons, electrons, and neutrons. That's me. Every single atom is going to have proton, electron, and neutrons in the basic form, and the distribution of the electron, proton, and neutron are like this. The atom have a nucleus where all the protons and neutrons are located. And around the nucleus, we have the electrons that are always in constant motion. And if we can see right here, we have a sketch of the atom where we have in the center the nucleus. And in this nucleus right here, we have the protons and the neutrons. Now, this circle right here that is the nucleus, you need to understand something. First is, this nucleus is really small. That's the first point. Second is that these protons and neutrons, they cannot go out from the nucleus. They are like in jail. They cannot go out. They cannot move out from the nucleus. Protons and neutrons are always going to be in the nucleus, and they're going to stay there forever. Now, around the nucleus, we have the electrons. Now, these electrons, let me try to draw right here what will be the outside of the atom. They're going to be moving free around the nucleus in the atom. That means I can think like this part right here, okay? Now, what happened? Around the nucleus, between this wall of the nucleus, let me draw again, between this wall around the atoms and the nucleus right here, everything is empty space. That means there is nothing. The only thing that is right there is all these electrons that right here, yeah, that they're moving like crazy around and around and around without stopping. But it's empty space, okay? That means there is nothing else there that the electron moving and moving and moving, okay? Now, let's go here. We can see that this is the atom where we have the nucleus with the neutrons and protons, and around we have the electrons. Okay? And something that you need to understand that these sketches are not real, because if this is the atom, the nucleus will be like a dot in the center. This is how small it's going to be the nucleus compared to the size of the atom. Now, we need to understand that all this space around here is what? Empty space where the electrons are always in motion, okay? Now, the majority of the mass is going to be in the nucleus. See right here, the majority of the mass is going to be located in the nucleus. And why? Since I say that all this space right here is what? It's empty. That means all the mass is only in this red dot that is right here in the center. And a little bit in the electron, but most of the mass always in an atom is going to be in the nucleus. Okay? Now, let's continue. I said, yeah, that the nucleus of the atom is very small compared to the size of the atom. Now, something that you need to know is that electrons, they can move between different atoms. And you guys know that. The only thing is I don't explain it with electron and proton, but I explain it with negative and positive charge. That I told you before that we had the positive charges and the negative, and that the negative can go out or in. They can move in and out from an atom. And here the name is going to be electron. These are the particles that can move in and out. But protons, they do not move. Protons and neutrons are always going to be in the nucleus without any type of motion. Guys, I need you in your notebook to write these 2 points because they are really, really, really important. Okay? Also, everything that is in red, but these 2 are really, really important. Now, how I say, let's go again. Since all things are made of atoms, and atoms are almost empty space, almost empty, that means almost everything in the universe is empty space. Okay? This sounds weird, but it's like that. Now, let's go right here. Proton and electron, they have the same magnitude of charge. And you need to remember that the word magnitude means that they have the same quantity of charge. They have the same number of charge. Okay? Now, the only difference is going to be that the charge of the electron is going to be negative and the charge of the proton is going to be positive. And see over here, positive and negative. But the magnitude, the number, the quantity of the charge is exactly the same. That is 1.6 times 10 to the negative 19. Now, the charge of the electron is negative 1.6 and the charge of the proton is 1.6. Remember, times 10 to the negative 19. And the charge of the neutron is equal to what? 0, guys. Neutron, they don't have any electric charge. Okay? Now, symbols. The symbol for electron is going to be negative E. Symbol for proton is going to be positive E. And neutron is going to be N. Now, see right here. Now, if you guys know, in the nucleus, we have the neutrons. I'm going to write N. In the nucleus, we also have the protons that are positive E. And outside of the nucleus, we have the electrons that are negative E. Okay? And this is something that we need to remember. Now, using this draw that I just made, let me go here and do it again. Atoms that are always neutral. Now, they want to be neutral. Now, motion of electron can make them positive or negative, but they want to be neutral, and basically they're supposed to be neutral. Now, why they are electrically neutral? Because they have the same quantity of electrons and protons. And let me draw it right here. We have neutrons and neutrons. Then we have 1 proton, 2, 3. And we have 1, 2, 3 electrons. That means this atom is going to be neutral. And why is going to be neutral? See it right here. Since we have in this one 1, 2, 3 protons. And we have, let me check right here, 1, 2, 3 electrons. If we find the charge of this atom, this is what we need to do. To find the charge, we need to add everything. I mean, we're going to add 3 protons and 3 electrons is going to give me what? 0. Okay? Now, electron, remember, they are what? Negative. That means it's always good to put the negative right here, then you will remember. These are the electrons, these are the protons, okay? You are going to add them, and then the charge is going to be 0, and the charge is going to be 0. That means they are neutral because they have the same quantity of electrons and protons. Now, what is going to change right here? If an atom gains an electron, they are more electron than proton, is going to be called negative ion. Let me draw exactly the same in this one. We have 1, 2, 1, 2, 3. And then right here we had 3 electrons now. If we have an electron in the outside, and then this atom gain 1 electron, now he have what? 4 electrons. And when we find the charge of this object, of this atom, we have 4 electrons, and we have 3 protons. And if we find the charge of the object, we have 3 protons and negative 4 electrons. This is going to be equal to negative 1. I mean, the charge of this one is negative, and if the charge is negative, the name is going to be negative ion. Okay? And let's go to another one. Let me do here 1 second the draw. And this one we got, it was 3. And then this is negative, yeah? Negative 1, negative 2, negative 3. Now, let's go to the problem. When an atom loses electrons, it has more protons than electrons, it's going to be called positive ion. And let's see what happens right here. If this atom, this electron that is right here, go out of the atom, it goes out. That means we lose 1 electron. And now we want to calculate what is the charge of the atom. We have 3 protons. This doesn't change, remember, because they cannot go out. But we have only 2 electrons. This is what happens when we find the charge. We have 3 and negative 2 is going to be equal to positive 1. That is going to mean that this atom is not neutral. This atom have the same quantity of, doesn't have the same quantity of positive and negative. He is going to be what? A positive ion, since the charge is positive. Okay? Let's go to the last 3. This example, I want you to have it in the notebook, also the last 3. But these one are going to be similar of the homework that you are going to have for tomorrow. Now, see what I want you to do tomorrow with this problem. Now, for the first one, guys, this is what I want you to do. In the first one, first thing that we're going to find are the quantity of electrons. And then see right here, we have 1, 2, 3, 4, 5 electrons. I mean, you are going to right here 5. Protons, we have 1, 2, 3 protons. And we need to find the total charge. And remember, for the total charge, we need to add the quantity of electrons and protons. It's always good to write the negative in front of the electron, and then you remember when you are going to add them. We have 5 electrons and 3 protons, this is going to give me a charge of -2. Now, if the charge is negative, you need to remember that the name is going to be what? Negative ion. Okay? And this is going to be the name of this atom. It's going to be a negative ion. Okay? Since it had more electrons than protons. Now, let's go to the second one. Second problem. In this problem, we have 1 electron, 2 electrons. And for the protons, we have 1, 2, and 3. We have 3 protons right here. Same, we want to find the total charge. We are going to add electrons and protons. We have 2 electrons and 3 protons. This is going to be equal to what? Positive 1. Okay? That means right here that since this atom is positive, it's going to be what? The name is going to be positive ion. And this is something that you guys need to know. When the charge is negative, it's a negative ion. When the charge is positive, it's a positive ion. I think it's really easy to remember. And last one for today is this one. We have 1, 2, 3 electrons, -3. And we have 1, 2, 3 protons. Now, total charge, we are going to add everything, -3, +3. This is going to equal to what? 0. Now, in this one, this atom is what? Neutral. It's going to be neutral since have the same quantity of electrons and protons. That means here we have a neutral atom. And remember, I want you to try to write these examples in your notebook, these three that are right here also. And also try to have the majority of the points that are in red, and then take a picture and upload the picture in your Google Classroom, and this is going to be the classwork for today.